Please, please turn off your mic. Okay, now this is the effect of pressure, volume, and concentration. Now the effect of temperature is very, very important. And so much confusion about it. But I will explain this thing in a very, very easy way. Effect of temperature. So effect of temperature means, if you will classify the reaction in the effect of temperature, it will be two types. One is exothermic and one is endothermic. Exothermic and endothermic. Graph is very easy. For exothermic reaction, the reactant has higher energy than the product. This is product, this is reactant. And in case of what is, just wait, Ronak, I will explain. So in endothermic, this is product, this is reactant. It is very easy to memorize the endo and exo. In exothermic, you can see reactant has high energy, product has lower, but in endothermic, reactant has lower energy and product has higher energy. And one more thing, the sign of delta H. Delta H will be negative for exo and positive for endo. And one more thing I want to tell you. For exothermic reaction, if you have any reaction A plus B, that is going C. So for exothermic reaction, heat is always be written in the product side. So you can write over heat. And for endothermic reaction, heat is always written towards the, means in the side of the reactant, means heat plus A plus B, that will give you C. So for endothermic, heat is written in the side of reactant, and for exothermic, heat will be written in the side of product. Any doubt? Tell me. No doubt, no doubt. Okay. Sorry. So what will happen if you, for exothermic, what will happen if you will increase the temperature? What will happen? As you can see, I told you in a very first slide, product heat is in the product side. It means if heat is in the product side, it means the temperature, if you will increase the temperature, it means product has a higher temperature because it has a heat. So reactant has lower temperature. It means equilibrium will shift in the backward direction if you will increase the temperature in case of exothermic. And for endothermic, if you will raise the temperature, what will happen? Here we have a heat in the reactant side. It means product has lower heat. So reaction will move in the product side. So this is forward. So now you can memorize a very easy way. For exothermic, increase on temperature, reaction will move in the backward. While for endothermic, increase in temperature, reaction will move in the forward. Any doubt? My request to everyone, any doubt about this, the effect of temperature for exo and endo? No doubt, no doubt, perfect. But the biggest problem is that how you will identify which reaction is exothermic and which reaction is endothermic. This is the problem. So I will tell you how to identify exo and endo. Sometimes it is given in the question and sometimes it will not given in the question. So listen me. Every dissociation reaction is endothermic. Dissociation means suppose you have AB breaks into A plus B. So this is a dissociation. And A plus B will make AB. It means it is association. If dissociation is endo, it means association is exo. Any doubt? Why dissociation is endothermic? Because in dissociation reaction, you will give the heat to the reactant molecule, then it will break. Okay? Any doubt about dissociation and association? No doubt, no doubt, no doubt. Okay. What about this reaction? Means my question is here, for this reaction N2 plus 3H2, that will give you 2 ammonia. What will happen means, what is the direction of equilibrium on increasing temperature? Direction of equilibrium. A very good question. Direction of equilibrium. Tell me, what should be the direction of equilibrium when you will increase the temperature? Okay. First of all, you will have to identify what is the nature of this reaction, exo or endo. As you can see, this is association reaction because N2 combined with H2, that will give you ammonia. So this is association. Association means exothermic. And exo means delta H is negative, and you can write the heat in product side. So when you will write heat in the product side, you can see product has higher heat and reactant has lower heat. So on increasing temperature, equilibrium will shift in the backward direction. Any doubt? Perfect. What about this one? Wait, this one. My question is, what will happen? Means, what is the direction of equilibrium if you will increase the temperature? Yes, this is dissociation, which is endothermic. Endothermic means heat is written in the reactant side. If heat is written in the reactant side, it means reaction will move in the product side, means forward direction. Perfect. So on increasing temperature, this is a dissociation reaction. Dissociation means endothermic. And endothermic means this should have heat here. So if you will increase your temperature, equilibrium will shift in the forward. So this is the effect of temperature. Now we can move to the next effect. Addition of inert gas. Addition of inert gas. Inert gas like xenon, krypton, this one. Okay. So right here, addition of inert gas. Here we have two conditions in the addition of inert gas. The condition number one, that is at constant volume and at constant pressure. So in case of constant volume, equilibrium will not affect, no effect. No effect. While in case of constant pressure, equilibrium will shift in that direction where the gaseous moles are more. Gaseous moles are more. Okay. And the last is effect of catalyst. It will not affect the equilibrium. It will not affect the equilibrium. Ronak is saying why? Why at constant pressure gaseous mole are more means equilibrium will favor in the means higher number of moles. You know, you can explain this one on the behalf of PV is equal to nRT. So volume, you can see volume directly proportional to number of moles. And partial pressure expression is N upon total mole, NT, total mole into pressure. So if you will take your pressure constant, you can see partial pressure is inversely proportional to the number of total mole. You can see here. Means total mole if increase, then partial pressure will decrease. So if partial pressure will decrease, then you can say equilibrium will shift in the that direction where the number of moles is higher. And you can easily memorize this one in case of addition of inert gas, and it is very rare as well. In GAMSAT, the addition of inert gas effect is not very common one. So you can say at constant volume, no effect, but at case of constant pressure, it will be shift in that direction where the gaseous moles are more. Okay. So this is all about your chemical equilibrium. Now I can discuss some questions. So yeah, we have this question. We have this one. Yes, this one. So I have not informed you about entropy. The first question is about entropy. So first, let me discuss about entropy. What is entropy? Listen. Entropy is represented by S, and it is a randomness of the system. Greater the randomness, higher will be the entropy. Okay. Greater the randomness, higher will be entropy. And you know that randomness is greater in the gaseous phase, then liquid, and then solid. So this is the entropy order. If suppose you have same phase, suppose two-way gas, B gas, and C gas, then what should be the order of entropy? So listen, as you can see, they are all gaseous phase, but reactant has 3 mole and product has just 1 mole. So when you will move in forward direction, you can see your gaseous mole are decreasing. So 3 and 1, it means your randomness will decrease. So delta S will be negative. Because more the number of moles, more will be entropy, because randomness will be higher. Why gases has more randomness? Because they have higher number of moles than liquid, than solid. So you can say whenever your number of mole will increase, your delta S will increase, means entropy will increase. If your mole is decreasing, entropy will decrease. Simple. Any doubt about entropy? Okay. What will happen if you will convert water liquid to vapor? What will be entropy? Positive or negative? Listen, less than 0 means negative. Entropy less than 0, it means negative. Entropy greater than 0, it means positive. What should be? Liquid to vapor. Vapor has higher randomness. It means positive. Yes, entropy will be positive. Simple. What about for this reaction? PCl5 breaks PCl3 plus Cl2. What is the sign of delta H as well as delta S? Tell me. Enthalpy, entropy, both. What is the sign of delta H and delta S? Yes, this is endothermic because this is dissociation. So endothermic means delta H is positive. Very good. And what about entropy? Yes, you can see product has 2 mole, reactant has just 1 mole. So mole is increasing. If mole is increasing, it means aeroentropy will increase. So both will be positive. Perfect. Well done. Now we can move to the question number 60. So the question is here, as the first equation proceed to the right. Proceed to the right means towards the forward direction, the first equation. So entropy is increase, decrease, remain same. What will happen? Tell me, A, B, C, D. Please respond me, everyone. Yes, everyone is saying B. Yes, entropy will decrease because reactant has higher number of moles, which is 3, and product has just, okay. This for the equation 1. What about equation 2? If you will move in the forward, what about equation 2? What should be the sign? Positive or negative? Yes, it will increase. Increase means greater than 0, and greater than 0 means positive. Okay. Perfect. Yeah, you can say K means Kc. Yes, yes, yes. What about 61? If you look at the 61, which of the following is closest to the equilibrium constant for this reaction at STP? This STP is given. This is your reaction 2NO2 and N2O4. This is your original reaction. And they have given this reaction. And you have to find the K for this reaction. Suppose this is K dash. Listen me. If you can see this reaction, the top 2 reaction, here you have a product side has NO2 molecule. Okay. And N2O4 is present in the reactant side. Any doubt? This is present in the reactant side. N2O4. But in the original reaction, N2O4 is present in the product side. If you will revert the second equation, suppose this is first, this is second. If I will revert the second equation, means like this 2NO2, that will give N2O4. So this K will also revert, that will become 1 upon 4.6 into 10 to the power minus 3. And this top reaction, I will remain the same, means 2NO plus O2, that will give you 2NO2. And now you can add them. You can see this NO2 will cancel out, and you can see original reaction have no NO2. So you have 2NO2, 2NO plus O2, and that will give you N2O4. What we have done in this question, we did the second equation reverse, and one as a same one. This is same. So what will happen? K1 into 1 upon K2. This is K2 supposed to be, this is K1. So K1 remains same. K2, I just reverse this one. So 1 upon K2. Now you can put these values. So K1 value is 6.4 into 10 to the power minus 5. K2 value is 4.6 into 10 to the power minus 3. So now you can see minus 3, minus 5 cancel out. That will be minus 2. And this is nearly 2, you can say. So means 1.5 approx. So you can say 10 to the power minus 2 is only this option. So I think D should be the right choice. Any doubt about this? It makes sense how it goes. Yes, I can explain again. Listen me. First of all, compare your original reaction with the given reaction. Listen me. Here you can see N2O4 in the is present in the product side in original reaction. In the second equation, N2O4 is given, but it is present in the reactant side. So if it is present in the reactant side, I will convert this into product side by reverse this reaction. Means 2NO2, that will give you N2O4. And this will become 1 upon 4.6 into 10 power minus 3. And this 2NO and O2, 2NO and O2 that is present in the reactant side means same. So there is no need to change the first equation, no change. And now you can easily add them. So as you can see, this NO2, 2 in the reactant, this is in product, that will cancel out. And overall reaction will be the same like this. So 6.4 into 10 to the power minus 5 upon 4.6 into 10 to the power minus 3. Any doubt? If you have doubt again, I will clear it this one again. We will see our final equation and try to make the first and two in the same like final. Yes, we will multiply with, yes, we will multiply with, K1 dot K2. Because whenever you will add any reaction, this K will be multiplied, K1 dot K2. Whenever you will add them. So this one is 61. Now we can move to the 62. So this one is talking about Gibbs free energy. I have not explained Gibbs free energy yet, but I can tell you some information about Gibbs free energy. Well, Gibbs free energy is used for the spontaneity of reaction. If delta G is negative, the reaction will be spontaneous. If delta G is positive, reaction will be non-spontaneous. And if delta G is equal to 0, it means reaction will be equilibrium. Okay. If you remember your expression of K, I told you K is concentration of product upon reactant. And suppose if your concentration of product and concentration of reactant is same, product concentration and reactant concentration is same, then you can see K is equal to 1. And you know that it happens at equilibrium. So equilibrium K is becomes 1. And if K is become 1, and you know that delta G at equilibrium will be 0. So this should be 0. Any doubt? You can write this line as a note point, so it makes sense to you. Whenever k is equal to 1, your delta G will be 0. And whenever k is greater than 1, your delta G is less than 0. And whenever k is less than 1, your delta G greater than 0. Please write down. Yes, 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 equilibrium will not change. Delta G will explain spontaneity of a reaction, spontaneity. Any doubt about this question? Please tell me. Yeah, the question is what should be the answer? Yes, answer will be gives free energy must be, that should be 0 because reaction is at equilibrium. Why equilibrium? Because k value is given, that is 1. If k is 1, it means delta G will be 0. Listen, k will never be possible to. K will not be possible to. K has only 3 conditions. It may be greater than 0, it may be less than 0, or it may be equal to 1. Only 3 possibility k has. It will not be like 3, 4, okay? So it's greater, equal, and less. And I told you the condition. Note this. Now we can discuss few more questions. Yes, this one. Who will try this? Come on, tell me. This becomes very easy after my explanation. The question is here, we have a reaction N2H2 that will give you ammonia. First of all, this is association. Association is an exothermic. Exothermic means delta H will be negative. Okay. So the first question is 45. Is the synthesis reaction endothermic or exothermic? So tell me what is this? Exo or endo? Yes, exo. Most of the answer is exo. Yes, it is exo. Very good. And the next question is, will increase pressure at constant temperature, what will be the rate of reaction? Oh, rate of reaction. Basically, I thought I will explain the rate of reaction property in kinetics maybe tomorrow, but it is in question, so I will just give you a basic idea about rate of reaction. Suppose you have a beaker and here we have a few gaseous molecule. If you will increase your temperature, what will happen? If you will increase your temperature, the number of collision will increase. And number of collision will increase, it means rate of reaction will increase. Okay. What will happen if you have constant temperature? Temperature supposed to be constant. Temperature is constant. So if you will increase your pressure, pressure increase means suppose you have a beaker and you have a molecule and you have a piston. So when you will increase your pressure, so you can see your volume will decrease. If volume will decrease, the molecule are very closer to each other. If they are very close, it means the collision will be high. Again, the number of collision will be high. And you can take the example of pressure cooker. So number of collision will high. So it means number of collision will high. It means rate of reaction again high. So pressure increase, temperature increase, your rate of reaction will high. It makes sense to you? Tell me. Yes. Whenever you will increase the pressure, collision will definitely increases and rate of reaction will increase. So what should be the in 45? What should be the answer? Just give me a second. I'm coming back. Sorry for this. Okay. So I think answer should be uh, exothermic and increase. Yes, D will be the right choice. Okay, what about 46? He's saying that the question is, which of the following is the most likely combination of factor needed to manufacturing process? It means manufacturing process means favorable condition. Favorable condition. It means at which condition the reaction is spontaneous. So tell me, means spontaneous means forward. Forward means favorable. Favorable means production of ammonia is high. So what should be the option? Tell me. We have only 7 minutes left. I got only one answer right now. Someone is saying A, someone is saying C. Listen, if you will look at the combinations, the pressure and temperature, I told you in a very first, just recently, pressure increase and temperature increase, both will favor the rate of reaction fast. It means your pressure and temperature must be high. Both should be high. So which option both should have high? Only A. Okay, so there is no mean to check ammonia and hydrogen and ammonia. You can see A is pressure is high and temperature is high. Simple. Okay, if you want to check through ammonia, you can see ammonia is present in the product side. Ammonia is present in the product. So as you can see, when you will decrease the concentration of ammonia, decrease means remove. So when you will decrease or remove the concentration of ammonia, reaction will move in the forward direction according to Le principle. So removal of ammonia should be the right choice. And here hydrogen and nitrogen, if you want to proceed in forward, your nitrogen and hydrogen should be added, not to remove. Okay. It makes sense. Please tell me. No. Temperature should be high. Listen, whenever the question is related to rate of reaction, not the direction of equilibrium, because manufacturing process is a different thing and equilibrium direction is a different thing. Okay. So whenever the manufacturing condition or rate of reaction condition, temperature must be high. You cannot correlate high temperature means reactant has lower temperature, so reaction will move in that direction. No. You should correlate temperature with rate of reaction. Whenever it is, asked in terms of manufacturing process or favorable conditions, something like that. Any doubt? Please tell me any doubt about this. No doubt. Perfect. So we have covered our chemical equilibrium chapter, and I have discussed only, important part. Basically 95% things I have covered. And for the GAM set, this is an important topic. And the rest part is your delta G is equal to delta H minus T delta S. This equation. This is a very good equation basically. Delta G is equal to delta H minus T delta S. This delta G is Gibbs energy equation, Gibbs free energy. And delta H is enthalpy. Delta S is entropy. And T is temperature. And you know that whenever delta G is negative, reaction will be spontaneous. Spontaneous is forward. And whenever delta G is positive, reaction will be non-spontaneous. And whenever delta G is equal to 0, reaction will be at equilibrium. Note this. Okay. Suppose I am saying we have a equation delta G is equal to delta H minus T delta S. And I am saying this is delta H, this is delta S, and this is delta G. And this is the type of process. So suppose my delta H is greater, means positive, and delta S is negative. So what should be the sign of delta G? Tell me. Who will answer? Positive means high. So you can see delta H is high. Delta S is negative means lower. So you can see whenever you will subtract high value to low value, the sum will be positive, means delta G is positive. Any doubt about the first condition? Tell me. No doubt. Perfect. Perfect. Okay. So if delta G is positive, it means non-spontaneous. What will happen if your delta H is negative and delta S is positive? What will happen? This is negative. Delta H is negative and delta S is positive. What should be the sign of delta G? Yes, it will be negative. It makes sense to you how it works. Delta H is less and delta S is high. It means this value is high now. So if you have high value and here you have lower value and you are going to subtract this one, so sign must be negative. And negative means spontaneous. Okay. What about this one? If this is positive and this is positive, and I am talking about high temperature this time. High temperature means now the role of temperature will come. Listen. I am saying delta H is positive and S is also positive. And we are going to take temperature as a high. So high temperature means T delta S is high. This sum will be higher. If this sum will be higher, then what will happen? Then again the same thing, means delta H G will become negative. Yes, it will be negative. So delta G will become negative at high temperature. Then reaction will become as a spontaneous. So we have a less than 1 minute. Don't worry, I will send you the table in the group. So you can easily, write in your copy and you can compare your answer. Any doubt about this table? And the question will be based on this table, means they will give you a reaction and they will say delta H is negative, delta S is positive, then what will be delta G? Okay, no doubt. Perfect. No doubt. Yes. We'll get the access to the recording. Yeah, you can, I will send you the record.